Today's lesson is linear regression. You're going to need either a TI calculator or have access to Microsoft Excel. If you don't have either one of those, then you're not going to be able to do this work. You need one of those two resources. So our learning targets. I will know how to find the equation of a regression line. I will know how to predict y values using that regression line. Okay. First, you have to verify that it's linear. So which means you have to plot the data. You have to do the scatter plot. If the scatter plot looks like it's a parabola, then you can't do linear regression. You have to do quadratic regression. If it looks a different shape, you have to use that shape. But in this lesson, everything's going to be linear. All right, so you have an x and a y. X being the independent variable and y being the dependent variable. So when you figure out the line of regression, it is going to be equation. A residual. The difference between the observed y value and the predicted y value for a given x value on the line. It's a definition. You should know that. So a residual, d sub I, is the observed value minus predicted value. So you have to have the line first, right? So you have to come up with this equation. Regression line. This is a line of best fit. This is not some arbitrary line just drawn through your scatter plot that looks good. There's actually an equation for it. I'm going to show you the equation, but we're going to use technology to come up with the answer. We're not going to do it longhand. This is the age of technology. Why should we do, if you're going to dig a pool, why would you do it with a shovel? You get a backhoe and be done in one day, versus a shovel will take you 3 weeks. What you want to end up with is y equals mx plus b. M being the slope and b is the y-intercept. And y sub cap is the predicted y value. It's not the actual y value, because in real life, all your y values are dependent on the independent input. So it's a scatter plot. It's not a straight line. Life is not a straight line. So this is how you come up with m. We're not going to do it this way. You don't have to know this equation. So let's move on. This is how you come up with the y-intercept. Y bar is the mean of all the y values. X bar is the mean of all the x values. We're not going to do it this way. This is the long way. This is the shovel way. We're going to use the backhoe way. The regression line always passes through the point x bar, y bar. Okay. So, finding the equation of regression line. Okay. I'm going to show you how to do this on a TI calculator. All right. So you have this data. Okay. For those of you who have a TI calculator, 83, 84, let's do it. First, you push stat. Then you push 1 for edit. Now, if perchance you have data already in L1 and L2, what I want you to do is navigate up to L1. See how my L1 is highlighted? Then you do clear, enter. Then you go over to L2, go up to L2 block, see that it's highlighted. and you do clear, enter. And it will erase the entire column. All right, we want to be back over at L1. We have the data from our slide, so let's put in all our independent values, our x's. 1.6, enter. 3.6, enter. 4.9, enter. 1.1, enter. 0.9, enter. 2.9, enter. 2.7, enter. 2.3, enter. 1.6, enter. 1.5, enter. Those are all our x values, our independent variable. Now, push the right cursor, and now we have to put in their corresponding y values. 428.2, enter. 828.8, enter. 1214.2, enter. 444.6, enter. 264, enter. 415.3, enter. 571.8, enter. 454.9, enter. 358.7, enter. And 573.5, enter. For every x, you have to have a y value. All right, once we're done with that, I highly suggest that you have diagnostics on, because it may give you more information than you want, but during the classwork or the test, diagnostics on will give you the information that you need. So let's go over how to get diagnostics on. Go second, catalog, which is a 0. Push the D, because it'll jump to the D, because diagnostics starts with a D. So X to the -1 button. Then we scroll down till you see diagnostics on. All right, there's diagnostics on. Press enter. I'm going to press enter. Press enter again. Okay, so my diagnostics is on. This is going to give me my correlation coefficient. I don't need it for today, but it's extra information that is valuable. Now, let's do our line of regression. Push stat. Go over to calc. We want number 4, linear regression. Then we're just going to push enter, 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 enter until we have our information. So our slope is 196.1519766, and our y-intercept is 102.2889342. The A goes here in the A. The B goes here in the B. And then you have your equation. Now, for a side note, R is 0.88. So that means our data points are going uphill. And it's 0.88 is pretty good. It's, you know, strong positive correlation. All right, so let's go back to our slides. Now they're going to do it the old-fashioned way. They have an Excel spreadsheet. They have x, y, xy, product of xy, x squared, y squared. They get all those values, and then they do those nasty formulas, and they come up with exactly the same thing. 196.152, which was our slope, and our y-intercept was 102.289. Exactly the same y-intercept that we got. So you can use the TI calculator. Just make sure you put in the data correctly and then follow those steps. And those are the points, and that black line is the line of best fit. Now, what happens if you don't have a TI calculator? Well, let's figure out how to do it using Excel. All right? There's three ways. There's Minitab. We're not going to use Minitab. There's Excel, and then there's the TI calculator. So this example is not the TI calculator. We're going to do Excel. All right? So we're going to do Excel to find out our 2 points. With this data, notice they got 12.48 and they got 33.68. Remember those numbers, all right? So we're going to get out of here. Well, let's go back here. See all this data? You want to take all this data, all that data, all this data, and you want to copy and paste it into an Excel spreadsheet. So all my data is right here. Okay, there's all my data from whatever they give you. So in here, for my slope, which is m, remember we're doing y equals mx plus b, our m, we want to use the function called slope. So you go up to formula. I have an Apple. So my Microsoft Apple product has the function under more functions. I do not know right off the top of my head where you find it on a PC version of Microsoft Word. So you just have to look for the function called slope. So I'm going to click on here, go to statistics, go to S's for slope. There's my slope. Now in here, they want all the Y's. So I'm going to highlight all my Y's. Okay, highlight just, what is it doing? No. Undo. What is going on here? All right. Doing something strange here. All right. So now we're going to get all our Y's. There's all our Y's. And we're going to get all our X's. And then you push done. And you get 12.48. Same numbers we did before. Then we're going to do the y-intercept. We're going to use the function called intercept. So I'm going to go to statistics, go down to I's, intercept. Once again, it wants all the Y's. So I'm going to do all the Y's. And then I want all the X's. And then we're done. Whoa, 33.68. Exactly the same thing as using the TI calculator or anything else. So our equation would be y equals 12.48x plus 33.68. That would be our linear regression equation. Let's go back. $12.48, 33.68. Same thing. Same thing with the TI calculator. 12.48, 33.68. Now, predicting a y value with an equation. I don't know if you ever heard of the term plug and chug, but it just means take the x value, put it into your equation, do the math, and figure out what the new y value is. It's nothing more than that. So predicting a y value is using your equation with a given x value. So 1.2 trillion is my x value. I plug it in and figure out my y value is 337.671. I put in 2 and I figure out my new y value is 494.593. My new x value is 2.5. I plug it in and I figure out my new y value is 592.669. Now these are predictions because the line of best fit is not going through every single data point. It's not actual data. It's a line of best fit that represents the data. All right, so what we learned today is how to find the equation of linear regression using the TI calculator and Excel. And we also predicted y values using a regression equation by plugging in the x value and calculating the new predicted y value.